Okay, welcome back, guys. This is going to be 14b, but it's the second kind of lesson of 14b where we're looking at our double angle identities. So for today's lesson, we're going to look at where these double angle identities come from, and they come from our angle sum identity earlier on. Now, I'm actually going to start with sine, and then we're going to do cos. The reason I wrote the order that way is because it will match kind of what's over here with our sheet. So if I have sine of a plus a, then this is also going to be equal to sine of 2a, right? Because a plus a gives 2 lots of a. But it's also, if I use my angle sum identity rule, it's also going to be equal to sine a cos a. It would normally be cos b, but in this case, they're both a, plus cos a sine a. Now, because they're being multiplied, I can flip my order around and it's fine. So what I really have here is 2 lots of sine a cos a. That's kind of really the only identity for our sine double angle kind of rule, or our double angle identity. You can see here it is written out by the textbook as well. And it's also going to be on our formula sheet as our first formula for our double angle rule. For the cosine one, though, it's a little bit more interesting. If we can remember what my cosine rule is, it looks like this. It's going to be cos of a, cos of b, but in this case, they're both a, minus sine of a. It normally would be sine b, but again, in this case, they are both a. So cos a minus sine a, which simplifies to give cos squared a minus sine squared a. Now that part all makes a lot of sense. The reason why we have a few kind of variations of this rule is if I think about my Pythagorean identity, I have the idea that sine squared, let me just write this over to the side. I have sine squared a plus cos squared a is equal to 1. So I can subtract either sine or cos from each side, and I can get cos squared a equals 1 minus sine squared a, or I could get sine squared a is equal to 1 minus cos squared a, just rearranging my Pythagorean identity. Now, if I do this with this part here, if I substitute this in, then that is going to equal 1 minus sine squared a minus sine squared a. That will give 1 minus 2 sine squared a, and that's kind of my final identity that I will see on my formula sheet. And I also will have this one here. If I do the same thing, but now I substitute the other part in, if I substitute sine squared a here into sine squared a, then I wind up with that being equal to cos squared a minus brackets 1 minus cos squared a, which in this case will equal 2 cos squared a minus 1. So these are kind of my four double angle identities, 3 of which are for cosine, 1 of which for sine, and again, all 4 of those are on the formula sheet. There's my sine double angle and my 2 variations. And there's the textbook printout as well. So let's use this to solve some of our problems here in example 8. Now, there's actually 2 methods we can look at to solve for example 8. Now, for my first method, this is going to look at us actually drawing a triangle. I know that tan theta is equal to 4/3. Tan is opposite over adjacent, which means that my opposite must be 4, my adjacent must be 3. Now, I can use Pythagoras' theorem to find my hypotenuse. So for my hypotenuse, that is going to be, let's just call it h, is equal to the square root of 4 squared plus 3 squared, which is going to equal the square root of 25, which equals 5, because this is one of my Pythagorean triads. So this length here is going to become 5. Let's put that in purple. This is going to become 5. So therefore, I can say that sine theta is equal to 4/5, and cos theta is equal to 3/5. Once I've got these two, I've got sine, I've got cos, I've got tan, I can now just substitute those in for my double angle. So if I do part A, that is going to mean that sine to theta is going to be equal to 2. Then it's going to be times 4/5 times 3/5. If I just use my double angle rule, which is this one here, 2 times sine A times cos A. If I solve for all of that, I'm going to get 24/25. For part B, for cos 2 theta, I could choose any one of those 3 rules that I have up here. I'm just going to choose the first one because, like I said, I have all my information for this question. If I just knew sine, I'd do the second one. If I only knew cos, I would do the third one. But because I know both, let's just do rule number 1, which is going to be 3/5 squared minus 4/5 squared, which in this case is just going to equal minus 7/25. For tan of 2 theta, tan of 2 theta is going to equal sine 2 theta over cos 2 theta. So I'm simply just going to be dividing by my two solutions over on that side. So it should give me a negative because I'm dividing a positive by a negative, which in this case is going to become minus 24/7. Okay, I'm going to call this method 1. I'm going to show a second method for how I could find sine and cos. So method 1 is to draw my triangle. Method 2 is to use our Pythagorean identities. So another way I could solve for this question is to use the second of my Pythagorean identities, which is tan squared theta plus 1 equals sec squared theta. So in order to do this, then that's going to become 4/3 squared plus 1 is equal to 1 cos squared theta. If I keep simplifying my algebra, that is going to give something that looks like 16/9 plus 1 is equal to 1 cos squared theta. So that is going to become 16/9 plus 1 is going to become 25/9 is equal to 1 cos squared theta. If I flip both of my fractions the other way, that's going to give cos squared theta equals 9/25. I can now square root both sides and I get cos theta is equal to 3/5. And I should put plus or minus here, but because everything's going to be in quadrant 1, I can just leave it as being a plus. So you can see I have cos theta equals 3/5, which is the same thing I got up over here. This might seem like this is a harder way, but I think it is worth knowing both methods. To find sine, I could do the other Pythagorean identity, which is going to be cot squared theta plus 1 equals cosec squared theta. And if I kind of fill in my math here, it's the reciprocal of tan. So this is going to become 3/4 this time squared. Plus 1 is equal to 1/sine squared theta. The rest of the working is going to be largely the same. So I'm going to get sine squared theta equals 16/25, which means sine theta equals 4/5. So it's just another method I could use to find my sine and cosine values. How I substitute those into the rules is going to stay exactly the same. We have two options. We can draw a triangle, which definitely looks a lot simpler and is a lot simpler in most cases. Or I could do this image here. Just bear in mind, these should be plus or minus because of the square root. It's just my boundary condition is telling me that it's in quadrant 1. So it's all going to be positive.